Welcome to the ICAO series on non-CO₂ aviation emissions. What are non-CO₂ aviation emissions? Beyond carbon emissions, an aircraft engine emits non-CO₂ emissions. What do we know about the climate impact of non-CO₂ aviation emissions? Based on the current scientific understanding, non-CO₂ aviation emissions have a net warming effect on the global climate. Each component of these emissions can have different impacts on the climate, and scientific uncertainties remain in fully assessing their radiative forcing. What is radiative forcing? Radiative forcing assesses the difference between the amount of energy entering the atmosphere and the amount of energy leaving it. If more radiation enters than exits, the result is a warming impact, known as positive radiative forcing. Conversely, when more energy leaves, it results in cooling, referred to as negative radiative forcing. What is the climate impact of NOx emissions? NOx emissions impact the concentrations of other greenhouse gases, such as ozone and methane. Although there is significant uncertainty, NOx emissions are likely to contribute to a net warming of climate. Increased ozone at cruise altitudes likely leads to a positive forcing, or warming, while other chemical reactions related to increased NOx may cause a negative radiative forcing, or cooling. This complexity makes it challenging to evaluate the overall climate impact of NOx. What about the climate impact of contrails? Contrails form when water vapor from a cruising aircraft condenses and rapidly freezes into ice crystals. While ice crystals can form solely with water droplets, more commonly they form as the result of water vapor on NVPM particles. The radiative forcing from contrails depends on their persistence and spread. Contrails that last more than beyond a few minutes are referred to as persistent contrails. Only the persistent contrails that spread to form contrail cirrus clouds may have a significant climate impact. Contrails evolve into cirrus-like clouds under atmospheric conditions called ice supersaturation. Understanding and predicting these ice supersaturated regions is essential to determining when and where contrails will persist, their climate impact, and how they can be possibly mitigated. There is likely a net positive, warming annual global average radiative forcing due to contrails and induced cirrus. However, many uncertainties remain. For example, contrails formed during the night likely have a positive, warming, radiative forcing, while those formed in the day could have a net negative or positive forcing. Around the world, initiatives are underway to improve our understanding of contrails, including advancements in climate and meteorological models, satellite observation, and in-flight measurements. Cross-sectoral research will be essential to reduce the scientific uncertainty and better quantify aviation's climate impact.